Okay, so welcome back. So now here's the theorem for the limit laws for algebraic expressions of sequences. Okay, so the algebraic limit laws as they apply to sequences, which is very similar to the way that the limit laws apply to functions. Okay, so it says given sequences a sub n and b sub n and any real number c, if there exist constants a and b such that the limit as n approaches infinity of a sub n equals a, and the limit of b sub n as n approaches infinity equals b, then the following limit laws hold. So the first one says the limit of a constant is just the constant. Okay, so there's no n involved, so it doesn't affect the constant. So it's just the constant. 2, if you have a constant times a sequence, the nth term of a sequence, then the limit as n approaches infinity of c times the nth term of the sequence is equal to c times the limit of the nth term, which again, if the limit exists, then it would be c times a. So again, you could pull the constant out of the limit. It's unaffected. Okay? 3, the limit of the sum or difference of two nth terms, so a sub n plus or minus b sub n, you can bring the limit inside the plus or minus. So basically you could distribute the limit. So what this is saying is that the limit of the sum or difference of sequences, the terms of the sequence, nth terms of the sequences, is equal to the sum or difference of the limits of the individual nth terms. Okay, so limit as n approaches infinity of the sum or difference of a sub n and b sub n is equal to the limit of a sub n plus or minus the limit of b sub n. Of course, it would just become a plus or minus b. Okay, and then similarly for the product, you have the same thing. The product, the limit of the product is the product of the limits, and so you get a times b. And then for 5, you get the limit of the quotient of the nth terms is equal to the quotient of the limits of each of the different nth terms, which then is a over b, provided that b is not equal to 0 and that the sequence b sub n is not 0 for all terms of the sequence. Okay? So again, b sub n can never be 0. Okay? Here. B sub n can never be 0, and b, the limit, cannot be equal to 0. Okay, so now I'm going to give a proof. So I'm going to go over the proof for number 3 here, the plus or minus. So I'm going to go over the proof, but the other proofs are similar in nature. Okay?